So in these inverse trig values, we're trying to find the exact value, which means we're going to have to use our unit circle and get all the values from the unit circle, or we can use your super chart if you have one of those that have all of the values for sine, cosine, tangent, cosecant, secant, and cotangent for every single angle on the unit circle. Okay, so we want to work from the parentheses out. So the first thing we're going to do is find the angle. At what angle is the sine value root 2 over 2? And from our unit circle, hopefully we should know that that occurs at the radian angle of pi over 4. So the sine is root 2 over 2 at pi over 4. And then the question says, what is the cosine at pi over 4? And the answer is root 2 over 2. Okay, and that is exact. That is not a decimal approximation, which is why we use our unit circle rather than a calculator. Okay, this next one says, at what angle, starts off, at what angle does the tangent have a value of root 3? And if you know your unit circle, that happens at the radian angle of pi over 3. Okay, because that's the root 3 over 2 divided by 1/2. Tangent is y over x. So that is what happens at root 3. So then the question is, what is the secant value at root 3? Secant is the inverse of the cosine. So the secant value at root 3 is positive 2.
6 million.
Okay, so the first thing we do is we find the angle from our inverse tan, or inverse cos, or inverse whatever, and then we evaluate another trig function. Okay, this one, we have the inverse sine of 1/3. Okay, which hopefully you know is not a unit circle answer. And whenever we have something not on a unit circle, we need to make our own triangle. Well, we'll make it a right triangle. How about that for trig? Okay, so because 1/3 is not on the unit circle, we can still find the angle whose sine is 1/3. So this is the angle whose sine is 1/3, which means I have an opposite side length, or a y value of 1, and a radius of 3, because sine is a ratio of the y over the r. So that just means I need to find my x value, and hopefully from Pythagoras, x squared plus 1 squared equals 3 squared. And I can figure out that nope, it's not root 10, it's root 8. 9 minus 1 is the square root of 8, or 2 roots of 2, if you are so inclined to reduce that. Okay, so I want the tangent. The tangent is the y value over the x value. Sorry, that's a y over x. So tan is 1 over root 8, which we could leave like that, or we could rationalize to be root 8 over 8. Okay, either way, that is how you do it. If you have a value that's not on the unit circle, you have to make your own triangle. So here we're looking at the inverse cosine, or the arc cosine, of the cosine at 5 pi over 4. Okay, and they don't just cancel out because the answer might not be in the right spot. So the first thing we do is we evaluate cosine at 5 pi over 4. Okay, and that is in the fourth quadrant down here. So the cosine at 5 pi over 4 is negative root 2 over 2. So now we want to find the other angle in the domain of arc cosine. Okay, so all the answers for arc cosine come from the top half of your unit circle. Okay, that is the domain of arc cosine, because on the top half of your unit circle, all of the x values are unique. Positive x values over here, negative x values over there. There are no repeaters whatsoever. So from the top half of our unit circle, at what angle does cosine have a negative root 2 over 2 value? And hopefully you know that that happens at 3 pi over 4. Okay, so all of the answers for cosine, arc cosine, should come from the top half of your unit circle, because that's the domain of, or rather that's the range of inverse cosine. Okay, in this last example, I believe, nope, there's one more. So here we have the inverse sine. At what angle is the sine 2 roots of 5 over 5? Okay, and of course, this is once again not a unit circle, one. So we have to make your own triangle, your own right triangle. And because sine is positive, we'll make it in the first quadrant. So this is the angle where the sine is 2 roots of 5 over 5. Once again, the sine is the y value over the r value. So all I have to do to find my secant is calculate the x value. So I'm going to apply some Pythagoras. X squared plus 2 roots of 5 squared equals 5 squared. So I need to square this mixed radical, and I square a mixed radical by squaring each parts and then multiplying them together. So 2 squared is 4, root 5 squared is 5, so 4 times 5 is 20. And if you're going to use your calculator to do that, make sure you have parentheses, or your calculator is not going to know what you mean. So the x value is root 5 for my triangle. So now that I know my x value, I can find the secant. The secant is the r over the x. So 5 over radical 5 is fine, but let's rationalize that. So we multiply it by root 5, okay, because that's how we get rid of roots. And we notice we can simplify a little bit more. So my final answer is just root 5. Okay, so we have a fraction that's not a unit circled answer, so you have to make your triangle and use Pythagoras to find the missing side so that we can calculate the secant. Okay, and then our last example here, at what angle is the sine negative 7 pi over 6? So if we follow this around, negative 7 pi over 6 is right here, okay, aka 5 pi over 6. And the sine at that point is 1/2. So then from sine, when else is the sine 1/2? Well, because sine has repeaters, the answers for sine always come from the right half of your unit circle, because that's a positive values on the top and negatives on the bottom. So we want from the right half of your unit circle the first angle where sine is 1/2. And hopefully you know that as being pi over 6.